We looked at Windows servers for hosting websites for HTTP. Now we're going to look at a Ubuntu, a Linux, Unix distribution, and see it running Apache. How is that different? What does it look like? You're going to find it's very much the same. Just once we get to the operating system, we're going to interact a little differently when we have a shell, when we're interacting with the actual machine. But most of it's going to look very similar up until that point. We have just a terminal, so let's get our IP address. It's that same IP address with a .3. So we use that. And it comes back with port 80 open. Let's look at just port 80 for a services scan. And it comes back with Apache HTTP 2.4.18. That's useful information. Now we'll take that and run script header. Sorry, script banner. And they should return banner information for us. The banner being the information that your machine receives the first time it connects remotely to another machine. In this situation, it says the server is in Apache 2.4.18 running on Ubuntu. Let's jump into MSF console, something we haven't done yet. With this protocol, the Metasploit framework comes with some very useful auxiliary modules, scanners that will enumerate all sorts of useful stuff for you. We're going to set our hosts to our IP address, and we can look at the options real fast. It's going to connect to port 80. It's not encrypted with SSL, so we don't need to negotiate SSL or TLS. If it was on port 443, it might be different. Should be different, would be different. Let's run this. That was fast. It came back with Apache 2.4.18, which is nothing new. It's what we kind of expected. Another thing we could do is curl our page. I'm going to pipe it to more just because I know it's going to give us a lot of information. More gives you one page at a time. The doc type is HTML. And here's that header information, which shows that it's Ubuntu 2. Can be quite useful. Another tool is going to be wget. Wget will retrieve web files. So if we ask it for the index file, which is usually the home page for a website, it will download it. And we see we've got index there, so we could cat index and pipe that to more. And it's the same file. Another tool we can look at is brow.sh. And we'll give it a startup URL. And it needs it as, no, that's fine. As an IP works. It's going to render in the command line what our website looks like. It looks like it's an Apache 2 Ubuntu default web page. This is all useful information that we would want to write down in our notes for enumeration. To get out of here, Control W. Another great tool is links, and you pass this one as the URL with an HTTP. And it's very similar to what we just saw, less GUI, more just reading and parsing out the text for you in something that's a little easier on the eyes than the default. HTML. Sure you want to quit? Yes. We could use derb, but we're going to jump back into MSF console since we've already done derb. And again, we'll use an auxiliary scanner for HTTP. This one is going to be brooders. Should be quite a few options. We'll set our hosts to our IP. Looks like all the yeses were filled. We will delete, run exploit rather than typing run. And what this will do is it's going to use a word list, one that comes with Metasploit framework, and see if it can't find some directories for us. So I found dir, I found source, and since it's the Ubuntu Apache default website, I'm not expecting to find many directories. If we did find more directories, that might be telling. And we'll look at the non-Metasploit version of that. Let's do derb. Instead of an IP address, give it a URL. And let's give it the same word list that we just used. The Metasploit framework. For directory.txt. Data word lists. That one went a lot faster. Came back with data and dir. Same as we found with Metasploit. The last thing we want to look at is the robots.txt. So robots.txt is what a search engine utilizes in order to understand which pages, which files are within bounds to spider and read and include in search results, and what files it doesn't want read, or maybe what browsers it doesn't want to be reading these things. So that robots.txt file can usually be very helpful. It could tell us all of the subdirectories and directories because it's got to tell the search engine to read or not read them. Sometimes you get all that information, other times you don't. But let's give it a try. In this case, we will hop back into Metasploit. It's very useful if you start doing things in Metasploit to just keep it up. If you only have one tab, you only have command line, then sometimes that's not an option. But we're going to use this HTTP robots.txt scanner. We'll set our R hosts. It's always best to check your options with Metasploit. Make sure that everything that says yes in the required column actually has a current setting that makes sense to us. 0.3 on 80. And we'll run that. That went pretty fast. So any user agents allowed, so any sort of browser works. Then we have these disallows, CGI bin, and junk. Maybe if it was the Gibson, it would say garbage. And we use the user agent of badbot. What was disallowed was no badbot dir. That could be useful if we did a curl of the website looking at CGI bin. Pop that to more just in case. We got a 404. Knowing that CGI bin exists might be helpful. In this case, got a 403 forbidden. So that could be potentially useful later for exploitation or for auditing. And with that, we've looked at now a Windows server running HTTP and a Linux server running HTTP. There's a lot more that you can get into with a website and with HTTP specifically, and we will cover that in its own section.